This is lesson 2.8 in elementary algebra, linear inequalities, and this is 2.8a. I'm assuming there's going to be several other videos that have to do with this. And I want to make you aware of one thing that's important for you to know. It's called set builder notation. And an example of that would be that there. And what that says is, what is x such that that line right there means such that x is greater than or equal to 3. Okay, so what is x such that x is greater than or equal to 3? What number can x be? It's going to be 3, 4, 5, 6, 7, 8. If you're talking about counting numbers, it's going to be decimals. It's going to be any number that's either 3 or bigger than 3. And that's called set builder notation. Alright, so just something to be aware of if you see that. Alright, let's go ahead and do an example here. Solve the inequality. X plus 5 is less than 7. So if you've done inequalities before, you know that they're done exactly like equalities. So you just pretend like that's an equal sign. So we subtract 5 from both sides, and we get x is less than 2. So what that tells us, in order for this to be a true statement, the number that we put in here for x has to be a number less than 2. It can't be 2 itself, because if we put 2 in there, we get 2 plus 5 is 7, and 7 is not less than 7. So it has to be a number smaller than 2. So if we put 1 in there, 1 plus 5 is 6. 6 is less than 7, so it works. So inequalities, greater thans or equal thans. Alright, let's look at example 2. We have x minus 6 less than or equal to negative 3. Again, we add 6 to both sides. Treat it just like an equal sign, but don't put an equal sign there. So x, in order for this statement to be true, x has to be a number equal to or less than 3. So let's put a 3 in there. 3 minus 6 is negative 3. Is that less than negative 3? No, but it's equal to. This little thing here means equal. So it can either be a number smaller than negative 3 or it can be negative 3. So 3 works. If I put a 0 in here, 0 minus 6 is negative 6. That's less than negative 3, so that works. Alright, so if we're going to graph this, we're going to make a line, and we're going to put 0 and 3, and it says it's less than or equal to 3. Whenever we're talking about numbers less than or equal to 3, we put a circle on the answer, and if it's got an equal sign there, we fill in that, and if it's less than, it includes all numbers less than 3. If this just said x is less than 3, then when we draw our dot on the 3 on our answer, it has to be open because it does not include the number 3. It only includes numbers that are smaller than 3. So that open circle means that it does not include the 3. And if we want to write this answer, we wrote it that way, we graphed it, and if we want to write it in set builder notation, we write it x such that x is less than or equal to 3. Okay, so this is my answer, and then I just write the x such that sign inside my cool little braces or parentheses or brackets or whatever those are. So those are your 3 different ways that you can write the answer. So let's look at example 3. It says 3a is less than 15. Again, we just pretend like it's an equal sign and solve it that way. So a is less than 5. If we want to graph it, we put the information that we have here. In A is less than 5, so we know that it's going to include numbers to the left of 5. And we have an open circle on 5 because there is not an equal sign. If it was written this way, then it would be a closed circle. Okay, so set builder notation. The set of A such that A is less than 5. So that's my answer right there. So those are my couple different ways of writing that. Alright, let's look at example 4 because we have a little tweak here that you've learned over the years, but let's just remind you. And I'm not going to go into why it works, but we're just going to do it. So in order to get rid of that -3, we're going to divide both sides by -3. Alright, so those go away. Now this is the key thing. Whenever you divide both sides by a negative number, this sign changes and flips over. 18 divided by -3 is -6. So we do it the same way. The only difference is that switches over. Now we're going to graph it. And we have 0 and -6. And it is a greater than or equal to sign, so we're going to fill in the dot. Now A is bigger than -6, so that means it's going to go that way. Whenever the variable is bigger than a number, we go to the right. Whenever it's smaller, we go to the left. Now in set builder notation, A such that A is greater than or equal to -6. And we're done. So example number 5, we have -x over 4 is greater than 2. So now what we're doing is we're getting rid of this 4 right here. Okay, so what I'm going to do, if you remember, I said that if you have a negative fraction and you have -1/2, -1 over 2, or 1 over -2, these are all the exact same thing. So what I'm going to do is I'm going to make this fit what I'm trying to solve here, just to make my life easier, because they have the negative sign in front. I'm going to put it down with the 4 so that I can take care of that at the same time. So how do I get rid of something on the bottom? I multiply both sides by -4. And when I multiply both sides by -4, again, it switches the sign. So that cancels. So I have x is less than -8 for an answer. So when I multiply by a negative or I divide by a negative, I switch the sign. So there's my answer. Set builder notation. And graphing. 0, negative, whoops, let's make this a little bit better. 0, -8. And it says that x is smaller than -8, so I know I'm going to go this way. And there is not an equal sign on there, it's just less than, so it's an open circle. And I'm done there with example number 5.